So, the next round that we're going to talk about, problem 11. At a college, approximately 2 out of 5 seniors go on to attend graduate school. If there are 750 seniors at the college, how many would be expected to attend graduate school? And so they give us several choices. So the most important information is that we take the information given in the problem, 2 out of 5, and convert that to a fraction. This is a ratio. We're going to essentially create a similar ratio using the total number of students. So in this case, 750. And then our unknown. So the unknown in this case is x. The easiest way to solve this problem is to cross multiply, because these two are exactly the same ratio. So 2 times 750 is 1500. And that's going to be equal to 5x. If you need to, you can always pull this number out and do the multiplication. You always have the freedom to do that. Here though, right, the next step is I need to divide both sides by 5. So x is going to be equal to 300. Now you could probably, if you looked at these answers, think about what you could throw out. You can easily throw out 75, because 2/5 is way more than 75 out of 750. And how do you know that? Well, 2/5 is the same as 40%. 10% of 750 is 75. So you know that A is no good. B actually is no good either. And if you keep going, you can kind of think about your reasoning and be like, well, if I just think about percentages, right, 10% of 750, right, is 75. 20% would be 150. 30%, right, is 75 times 3. 40% is 2 out of 5, or 300. So, just by doing these two, you could probably eliminate most of the answers that are available. Let's talk about number 12. Take a moment and read number 12 to yourself. Pull out the information from the problem that you think is most relevant. So it tells you that there are 1 million plus books in the Mills Library, and that the Springvale Library has 900,000 plus books. Which of the following is the best estimate of how many more books the Mills Library has than the Springvale Library? Well, let's think about this. If we're going to estimate, it's probably easier for us to estimate these numbers up or down, because we don't really want to have to do the subtraction, right, of all of these. That's complicated. It's going to take time. So let's actually look at the numbers that we have. Here, right, this million is fairly close just to 1 million. So let's start there with our estimate. And 907, 82. So if I took essentially the numbers that I had here, and I said, well, again, right, although that's 7,000, it's relatively small compared to the 900,000. Then I can ignore everything except for, so the zeros don't count, so then it's just 10 minus 9, or 1, and then the rest of the zeros, or 100,000. That's probably the easiest way to do this estimate. It's understandable though, right? If you're like, oh, I just want to double check. Double checking is something that you're going to come back to when you have a little bit more time. Right now you don't necessarily have time. That seems to be a reasonable answer. And certainly if you compare it to the other examples that are there, you know that it's not going to be 1,000 books. You know that it's not going to be 8,000 books. You know that it's not going to be 10,000 books. So that really gets you between A and B. And if you were worried, you could always go back and double check your calculation. But think about it this way. 7199 is very close to 7,082. So we can ignore both of these and just focus on the estimation that we did here. Any questions? Okay, take a moment, reflect on those two problems. If you had a plus because it was easy to do, right? Check your knowledge. Do you feel comfortable with the strategy that we used to solve that problem? If you had a minus and you were like, I'm just not comfortable, can you figure out what it was that you weren't comfortable with when solving that problem? So take a moment and reflect on your own learning. What made sense or didn't make sense?
I was confused. Like, how does it like 100,000? Because like, see how it has a 9?
Mm-hmm. So all I did here was think about the fact that 900,000 is a very big number, right? Relative to 7,000. So if I wanted to round up, right, I would have to have a much larger number than just the 7,000 to round up to 1,000,000. So in this case, it's easier to just round down to 900,000.
Okay. Let me show you the paper.
Other questions? Yeah?
Because you said like 9,000.
Uh-huh.
And you put the line like
Yep. So 10 minus 9 is?
1.
Yep.
Oh, so we go 10 minus 1.
Yep. 10 minus 9 is 1. Beautiful. And then it's 100,000.
Thanks.
Great job. Other questions? All right. Let's do 13. Go ahead and talk to your neighbor. Come up with your strategy for how you would solve this problem.
I've never seen this before. Reminds me what I did in middle school.
That's going to take so much time. Give that problem this time. See, because what I did is I was focusing on this place, so I skipped this 1, 2, 3, and then I just did the 1, 2, 3, circles, 1, 2, 3, and then 4 times 3 is 12, so I assumed
I'm going to bring us back together in 5, 4, 3, 2, 1. Okay, how did you estimate this? So we have 4,286 times 390. Oh, now I could certainly do that math and it would take me a little bit of time, but I could get there. There are a couple of other choices that I have though, so let's think about what the choices are. If, right, I just simplify this to 4,000, and I simplify this to 400, 4 times 4 is 16. Which gets me to, oh, I need one more 0. There we go. 1,600,000. That's one approach. But if you're like, I'm not sure that I'm comfortable with that estimation, that seems like too general an estimation. You could always simplify it a little bit less, right? So you could be more precise, and you could say, I'm going to do 4,300 times, right, 400. Right? So if you were worried about your simplification here, you could always just do a little bit less of a round, right? And that gives you a greater amount of precision. But let's talk about that for just a minute. They say, which of the following is the best estimate? What do you know you can get rid of right away? D and E. Oh, for sure, right? There's no way that those are even remote options. What's the other thing that you know you can get rid of? A, right? It's too big. There's no way you're going to get to A from those numbers. Now, granted, I think it's pretty hard to be able to tell the difference between 1.6 million and 1.2 million, so you really probably have to do some math to be able to check your answer. But you can at least narrow it down so that your choices are more reasonable. When does that matter? Well, probably the best way to think about this is you want to be able to answer as many questions on the CBEST as you possibly can. That's the reason why that plus-minus strategy is so valuable. You go through and you say, I know I'm comfortable answering these questions. You answer the ones you know you've got first. Then you go back to your minuses and you answer as many as you can, taking the time that it takes to solve them. But what happens if you're getting towards the end of the test and you're running out of time? Well, then you're going to use the strategies where you're trying to narrow down your choices so that it's only choosing between two. That gives you a greater probability of success. Granted, the reality is you can solve these problems if you were given enough time, but because it's a time-limited test, that's the challenge. So, all right, let's take a look at number 14. Sometimes a picture really helps. So it says the lowest point on Earth is the bottom of the Marianas Trench. At a depth of 35,840 feet below sea level. The highest point on Earth is the summit of Mount Everest, and that's at a height of 29,028, and that's at feet, above sea level. Which of the following is the best estimate of the distance between the lowest and the highest points? All they're asking for is this. They want the total distance between the two. In order to do that, I have to think about a couple of things. So they say this is sea level. The easiest thing to do is to add these together then. But I don't know that I want to take the time on the CBEST to go all the way through to do that math. I can, right? So 8, 6, 8, 4, 1. So 64,868. I can do that, right? Doing that math is not a problem. In which case, I could look and see, oh, I'm definitely going to choose D, 65,000. But I could make my life easier by recognizing the following. If I see this 840 and this 28 together gets me close to about 1,000. Right? Then I have 35 plus 29 plus 1. That's one way that I can estimate it. Another way that I can estimate it is to say, all right, I'm going to say that this is 36,000 and this is 29,000. But that's not necessarily the easiest math to do. The other way that I could do it is say, okay, I'm going to bump this 840 up here. I'm going to say this is 30,000 and this is 35,000. That's easier math to do, and that's an easier estimate. All of those are reasonable estimates to make. Here, I'm just adding them together, but maybe that's math that isn't as fast for me to do. It takes a little bit more time to think through. This is probably the fastest math to do. But if I was worried, if I wasn't sure, I could always do the calculation and then think about what the estimate would be. And that would give me a greater sense of confidence for where I was estimating. Other questions? The hardest part on estimation, I think, is having the confidence to know that what estimate you're making is a reasonable one. And that's why it's useful to be able to check your knowledge and be like, well, I think it should be, and then you can check the answers that are available. So I think it's fair for you to say, well, I'm not going to have to worry about A and B, which means my estimate has to fall somewhere between C, D, and E. And that's where my accuracy probably matters a little bit more, and if I'm worried, then I would check my calculation. Okay, take a moment, reflect on your learning. What made sense? What might you still have questions about? If you're not sure, it's always a great idea to ask. Questions are the most valuable piece of learning. Because when you ask, you can always learn more. Yes?
So for like that one, since we got, if we would have rounded up, it would have been closer to 2.5.
Mm-hmm. Yep. Yep.
Wait, how did we add the 1? Like 35 plus 29 plus 1?
Because you're making the assumption that if you are combining the 840 and the 28 feet, that gets you close
Okay,
to
then
1,000.
35,840 plus 29,028. So that's equals 64. 8, not 6, 8, so that's why.
That's why. Mm-hmm.
So you just add one more. No?
Yep, and that's how you get there.
Oh, okay.
Okay. Everybody all right? Let's do 15. Kim is in the 10th grade and takes a standardized test. Use his test scores below to answer the question that follows. Kim's test score indicates that A says he scored as well as or better than 72 of the test takers. That 72 is the raw score, so I can ignore A right away because 72 of the test takers has nothing to do with the raw score. So A isn't any good. I'm going to say no for A.
What is the raw score again?
So great question. So the raw score is just the total number correct out of the possible number that is correct. So for example, if there were 100 points on the test and you got 72 out of 100, your raw score would be 72. Right? Typically, you might convert that to a letter grade. So that's the reason why a raw score versus a letter grade might be useful. And then if you think about B, 28% of the test takers scored better than he did. Well, again, that refers to the raw score, right? He got 72 possible points. He missed 28 possible points. So that, again, B has nothing to do with, right, the table that we're given. 28% of the test takers, it's not relevant. It doesn't make sense for the information that's given. And again, that has to do with the raw score. So 100 minus 72 equals 28 points. But that has nothing to do with the number of students. So let's look at C. He would perform adequately in a 12th grade science class. Here's the challenge, right? That's a tempting one. It's tempting because the grade equivalent is 12.1. But adequately isn't a standard that's referenced. So they don't say what adequate is. So adequate would be if you gave a standard, say, standard would be 70 or higher, and if he scored a 72 or higher, then that would be adequate. But in this case, because you're not given a standard, C isn't a good option either. D is he scored as well or better than 88% of the test takers. So that's that second column where it says percentile. So percentile always refers to the number of individuals who took the test out of the total, right? So for example, if, right, 20 students took the test, right, and 15 of them, right, scored 70 or above, right, that would be the 80th percentile, right? So that's referencing the number of students. So that is a reasonable answer. But let's check E, just to be sure. So, E is he answered 72% of the questions correctly. Here's the challenge. They don't tell us the number of questions. They tell us the raw score, and we could do the calculation, right? But it doesn't tell us the number of total, so we can't do E. So E is not an option because we don't know total number of questions. Now, sometimes, yeah, go ahead.
So raw score doesn't necessarily mean it's out of 100?
Nope. Nope. It's just an example. Yeah?
So I know the answer is D.
Uh-huh.
Can you explain to us again what the percentile means?
Oh, yes.
Why that's the correct
Mhm.
one?
So, percentile in this case is like if I have a group of students, right? So these are all of my students, right? And I'm trying to make sense of whether or not they scored below a 70 or above a 70. Right? So here, right, it's above. Here it's below. So if I had 6 students in a class, right, and I had, let's say, one of them scored, right, let's do this way. We'll say 4 of my 6, so 4 out of my 6 is above 70, which means I have 2 out of 6 that are below 70. If I take a look at the total number of students in the class, right, the percentile is the number of students getting that score. So this is obviously a simplification, but right, if I think about converting that, right, to a fraction, right, 4/6 is 2/3, so roughly 67% of my students scored 70 or above. That's the percentile, or the number of students that got that score. So a good way to think about percentile is if you're thinking about a whole population, you're trying to decide, is that reasonable for the population? So for example, if your average student would score 70 or above, right, 67% of the population is pretty close to average. That makes sense, right? Then if I had a third, right, those are the students who are scoring below, right? And so if I was a student who scored in the 33rd percentile, right, then that tells me, oh, I might need to do additional work so that I move my score up to where the average population is performing. So percentiles just give you a sense of your whole group and then your performance relative to the group, or a student's performance relative to the group. Does that help?
Yes.
Somebody else asked me and they were like, there's no questions about this, but what's standing? And standing is if you were to take your numbers in terms of your distribution. Right? So normally we think of the distribution in terms of like 10, 20, 30, 40, 50. If you were to convert them to single numbers. So 9 would be the standing that would correspond to the 88th percentile. So that at least gives you a reference point. Again, they don't ask you about it, but sometimes it's kind of an odd word, and if you're not familiar with it, it could throw you off. Okay. Take a moment, reflect on your thinking. What'd you learn?
Can I look at this voice?
Yep, go for it. I'm just going to try and get the... I'm afraid that my eraser is doing less erasing and more spreading gray.
Do you have a sharpener?
All right. Let's take a look at 16. So the expression -105 plus -14 plus 34. What does that simplify to? So there are a couple of ways that you can think about solving this problem. Here's one way. You can make your life easier in terms of the math. If I subtract 14 from 34, that's going to give me 20, right? So, -105 plus 20 is a simplification of that problem. Here's the trick though, right? When I add these two together, is my answer going to be negative or positive? It's going to be negative. So what I can do is a little mental trick, and just think of it as subtracting 20 from 105. Just make sure that I give it the negative sign. So if I were to do that, right? Subtracting 20 from 100, right, gives me 80, and then the 5. So negative 85 would be my answer. But I kind of did a little bit of two-stepping there, right? So I said, I'm going to simplify and say 100 minus 20 gives me 80, and I ignored the 5, and I'm going to combine those together to get to my negative 85. That's one way of doing that math. All I'm doing is a little bit of estimating to make sure that I get to the correct answer. The real key part is that I know that it's negative. So if I know that it's a negative answer, I can eliminate D and E. Let's take a look at A, B, and C. So I know that A is not reasonable. Why? Why is A not reasonable? Well, if I think about this, right, if I were to subtract 30 from 100, right, that gets me roughly 70, right? Negative 57 is too small. It's too small a total magnitude, so I can ignore A. That leaves me with B and C. Maybe I didn't like that, right? Maybe that method of solving wasn't particularly helpful for me. So let's do it another way. Let's combine these two. So that's going to give me 105 and 14 is negative 119. So negative 119 and 34. I know my answer has to be negative, and then I can set up a subtraction to give me the total answer. Both of these are totally acceptable ways to solve a problem. Some of it just depends on you and what your preference is. Yes?
So when you have two negatives like that, you're adding?
Well, in this case, sorry. There we go. There's a plus in the information that's given. So in the information that they give you in the problem, there's the add signs between the two, which I actually, when I solve problems like this, so that I don't make a mistake, always box my symbols so I call attention to them. That's a really great way to help you keep from making mistakes. Because you're right, if it was multiply, right, a negative times a negative would be a positive.
So you did negative 105 minus 14?
No, because in this case, right, it's a negative plus a negative. The sign doesn't change. So they stay as negatives. So if I add them together, they're still going to be overall negative at the end. A good way to think about that is if on your number line, right, so here's a negative 5. If I'm adding negative 5 and negative 3, so here's negative 5, here's negative 3. When I add them together, I have negative 8. So you have to make sense of it on your number line. When you're doing addition between two negatives, they're going to keep their negative sign. Other questions? That was a great question. Thank you very much. Other questions? Okay, take a minute and reflect on your thinking.
Oh yeah, someone reminded me of doing PEMDAS. It's all here at Valley. This is really great, you know. Yes. So I can try to overcome my difficulties.
Okay. Let's do 17. So 17 says, use the information below to answer the question that follows. As part of a unit on weather, students recorded the outdoor temperature at 8:30 a.m. for 5 mornings. What was the difference between the week's highest and lowest morning temperatures? So here we go. Our lowest temperature was on Friday. That was negative 15 degrees. Our highest temperature was on Tuesday. That was 12 degrees. So if we want to think about the spread or the separation between them, here are a couple of things that we could do. You could individually count ticks, right? So if you weren't comfortable and you weren't sure, you could always use your number line. Right, so that's 15, and then that's 12. So if I think about this, this is 15, this is 12, so 15 plus 12 would be 27 degrees. That's one way to do that calculation. Or I could say 12 minus negative 15, right? And I know here a negative and a negative would be a positive if I'm multiplying, so 12 plus 15 also gets me to 27. So those are two ways that I could solve that problem. Both are appropriate, either are acceptable to use, but counting may be faster if you're comfortable with the number line.
Oh yeah, I should remember this. I remember doing this in middle school with accelerated math.
All right, so here we go. Let's think about number 18. A teacher has 3 packages of stickers. One package contains 56 stickers. Another package contains 48 stickers, and a third package contains 58 stickers. So I have 56 plus 48 plus 58 stickers. That's going to give me a total of 162. So if you prefer, you could also add them long ways. So for me, I combine these and I say, oh, that's 16. 16 and 6 gives me 2. Carry the 1. Right, so 5 and 4 is 9, and 5 is 14. 14 and 2 is 162. So you can combine these in any order. 6, 10. That's one way to speed up the math. Now, am I done? It says, if the teacher divides all the stickers equally among 27 students, how many stickers will each student have? So 27 into 162. Now, this is probably not multiplicative tables that you're familiar with, but, right, you can do a little bit of estimation, right? So, think about it this way. If you think about 27 times 2, right, that would get you to roughly about 50 something, right? Right, because 2 times 25 would be 50, right? Well, I'm well over 100, so that's at least 4, right? And 6 actually gets me pretty close. So let's try 6 and we'll check. So 162 times 6. Oh, sorry, 27 times 6. 27 times 6. So 6 times 7 is 42. Carry the 4. 6 times 2 is 12. Plus 4 is 162. So you can do a little bit of estimating where you say, hey, this is like 25. I know that 25 times 2 is 50. I know that 25 times 4 is 100. I know that 25 times 6 is 150. 150 is close to 162. So you can use something like this that's an estimation method to get you within the neighborhood, and then you can check to see whether or not your answer is reasonable. Does that make sense as a process? The other way that you could do this, right? If you're like, I don't know, Corin, that really doesn't work for me. It's just confusing. You could round, right? You could round until you get something that's close in proximity. So you could round 27 to 30, right? And you could think about, right, 30 going into 118. Yeah, so 30 into 180 maybe, right? And that would give you an approximation too, right? That gets you close. So those are two ways that you could estimate it. Okay, take a moment and look at number 19 while I'm erasing. Let's talk about 19. So what is the tens digit in the dividend of the problem below?
It's D, 5. Looks like it's going to be a 5. It's a 3, it looks like it's going to be B.
Okay, so here's the tricky bit. I really am thinking about what, right, multiplied plus a remainder would be correct. So one way that I can do this, right, is simply take 25 times 5. Well, if 25 times 4 is 100, 25 times 5 would be 125. If I add the 23, then it's 148. That's one way to think about solving the problem. But maybe you're like, oh, I don't know. That's maybe not the first thing that I would think about. Is there another way that I could solve this problem? Well, another way you could think about solving the problem is, if you think about, right, a remainder 23, right, you could think about what would be a number, right, that you could multiply by, and you could estimate, right? So they tell you 5, right? So 5 times 25, you could go through the process of actually right, and then add 23. So if you didn't immediately think of this as a multiplication table, you could still do the math to get there. That's an option too. But what it's asking you for is, right, the dividend is what's getting divided. So this number is the dividend. The remainder 23 is what's left over once you've essentially multiplied 5 by 25 together. All right.
Do you think you can move out of the way so I can see?
Yeah, of course. Questions? What you thinking? Let's read number 20. So last week Mario walked 7 3/4 miles. This week he walked 15 and 5/6 miles. What is the difference between the distance he walked this week, bless you, and the distance he walked last week? Okay, well, let's think about this, right? They want to know the difference, so I'm subtracting. Now, I have a couple of choices as to how I do this. I can do everything to convert to common denominators for everything, right? Take my mixed fraction, right, and convert it to a single fraction, but I don't really need to do that. Let's think about this. What's 15 minus 7? If I look at the answers then, that excludes D and E, right? So right away I can get rid of D and E. Now I have to think about 3/4 and 5/6. So let's convert those to a common denominator. Well, 3/4 is the same as 9/12, and 5/6 is the same as 10/12. 10/12 minus 9/12 is 1/12. So the answer is B. So,
How did we get the 9?
ooh, for sure. Let me show you. So here's 3/4, right? These are common ratios. So they have to have the same value with respect to each other. So if I set it equal, I'm going to say, hey, I need to find something that is common for both 4 and 6. What do both 4 and 6 go into? And so in this case, I'm going to say 12. So how do I do that? Well, 12 divided by 4 is 3. So 3 times 3 is 9/12. And I can do the same thing for 5/6. So 5 times 2, 6 goes into 12 2 times. So 5 times 2 is 10/12. Does that make sense? And then all I'm doing is 10 minus, so the 12 stay the same, and 10 minus 9 is 1. Okay. Any questions?
Oh yeah, so I have a question for number 19. So how did we do 4? Because like